Yeah, a couple of things about square roots. Let me highlight these before we get going on the test. Of course, we know that on a square root, well, a couple of things on it. If I'm going to do, say, the square root of 64, and let's just also go ahead and throw in x to the 8. Square root of 64 and x to the 8. Can I simplify that? Because sometimes, if you get the variables involved on these, there's a time when you can't simplify it, but this is not one. If it's multiplied, yeah, sure can. You can split those up, one way to think of it, and then simplify. Now, of course, square root of 64, 8 is it, because you square 8, you get 64. Now, what about the variables to the powers? Split it in half, okay? Yeah, it turns out the square root of a variable to a power, you just divide the power by 2. You know, even if it's a perfect square, say we got y to the 16th, the square root of y to the 16th is not y to the 4th, it's y to the 8th. So be careful on on those. Yeah, you divide by 2.
So what if
Power. We'll get to we'll do an odd power here in a second. Okay. Let me make a couple other points here. Now, can I split 49 over c squared? Yes, I can. I can split it. Divide, you can split. 7 over c, that would be, right? But what about this? X squared plus 25. That's one you can't split. Or one of the ones you can't split. Yeah, you can't simplify that. You can't split up a sum. What about this one? Can simplify that one? No. Same deal. Even though it looks like so easily could, you just can't. The numbers don't work. For a sum, x squared, the square root of a sum, the square root of a difference, you just can't split those up. It'd be very nice if you could, but the numbers just don't work out. Okay? So these ones you can. All right, now, another point here on, well, let's talk about this. What if I had the negative square root of 121 and compare that to the square root of negative 121? Both of them have 121 in them, but not the same answer either case, is it? This one, what have I got there? Negative 11. Because 121 square root is 11. Negate that, so you get negative 11. This one, however, well, we talked about that. If you have the square root of a negative, we have the I term, which is the square root of negative 1. So this is essentially negative 1 times 121 underneath the square root. So I've got that square root of negative 1 there. So this is not negative 11. This one's 11i. Yeah, that one's 11i. So be careful on the compare and contrast there of those two. If the negative's on the inside, you get that I. Now, having said that, we also did some cube roots. And what if I have a negative in a cube root? Is that an I? No, that one's not an I, because you can do a regular number for the cube root of a negative number, right? This is just going to be negative 3. 3, yeah. Be negative 3. There, because the cube root of a negative, that there's no problem there as far as having to find anything, but yeah. Okay? So those are square roots and cube roots. A little bit about what we did. We also talked about square roots, basically that didn't square root up nicely. Square root of 24, good example. If you got a square root of 24, that doesn't square root nicely. Square root of 25 is 5, but square root of 24 is 4.9 something. But now what we want to do is simplify that, and the way we do it is factor it up, right? For square root of 24, I'm going to take and split that apart by factoring it. 4 times 6. Because if I split it up into 4 times 6, the square root of 4 square roots nicely to be 2. Square root of 6 is not going to simplify any further. So 2 square root of 6 is what we would simplify square root of 24 to. Now if I had, let's see, square root of 108. Well, you may or may not see it there, but that one also, we can say 4 times something, and let's say we did that. Be 4 times, what would it be? 4 times 27. So we can break down the 108 that way. However, this will be 2 square root of 27. If I do it that way, there's still more to do in there, because 27, I can factor it to where I can simplify it. How? 9 and 3, okay? Yes, 27, I can break it down to 9 and 3, and that's going to be square root of 9 is 3, so I'd have 3 square root of 3, so I have 2 times 3, which is 6 square root of 3. So be sure you simplify all the way square root. Now, over here I can factor 6, but why don't I need to break it down any further? 6 is 2 and 3, and neither is the square root of 2 nor the square root of 3 simplifies, so that's why we stopped there on that one. But 27, we can do a little more with that. Okay? All right, now, same thing kind of on the square roots of odd numbers. Square root of x to the 11th. You know, powers we divide by 2, but that's not what we want to do here because that's an odd number, and that would give me a fraction, which is not quite what I have in mind. But what I do there is split that up. How do I? Well, I split it up into 2 x's. One of them is going to be what? One of them is going to be what? 10 and 1. Yeah. I'm going to split up 11 into 10 and 1. Yeah, I'm going to go, the next number down, 10, is an even number, so that's why I do 10. And then, of course, I need x to the 1 to make it 11. Split it up into x to the 10, x to the 11. Now I can simplify x to the 10 and x to the 11. Square root of x there. With me on that? Okay, all right. We also talked about what we do when we add radicals and subtract radicals and all that good stuff. Turns out on radicals, adding and subtracting wise, we have to have what? To add them. So I had the 4 square root of 3 plus 6 square root of 2 plus 7 square root of 3 minus 8 square root of 2. Okay. When I add radical terms like that, what do I have to have? I have to have like radicals. The radical has to be exactly the same. And so here, I've got 4 square root of 3 and I've got 7 square root of 3, so I can combine them, and they combine by, well, doing the numbers in front, right? 11 square root of 3, the square root of 3 stays square root of 3. Then I've also got 6 square root of 2 minus 8 square root of 2. Those are like radicals, so I combine them. 6 minus 8 is negative 2, and the square root of 2 is the same. And anything else? Can't do anything else. Not like radicals, so not going to simplify. So that's adding and subtracting, which also gets back to another point. If I have wind up with something like this, 6 plus 3 square root of 2, it's very tempting there to try to go ahead and add those. But can I add them? No. I can't add them there, can't simplify that. Reason being, it's not like radicals. That has a square root of 2. That one doesn't have a square root of 2 on it. The 6 doesn't. So I can't simplify those. That would be the final answer on that one. All right. So what else do we do? We on the radicals, well, we did multiply radicals, and this one, well, it's like any other time. You have a number in front, in parentheses, and beside the parentheses there, that's distributing. Yeah, I need to distribute the square root of 6. So multiply the square root of 6 times the square root of 2. That gives you square root of 12, of course. Then over here, we do the square root of 6 times 3 square root of 5. So what actually gets multiplied there, combined there? The 6 and the 5. Yeah, the stuff in the square root gets combined, so we get, what, 3 square root of 30? Right there. And then it's just a matter of combining the like, or simplifying, if we can, combining like radicals, but I don't have that. This right here simplifies with the 12, 4 and 3. That'll simplify to be 2 square root of 3, and this will be 3 square root of 30. Now square root of 30, can it simplify? We got 6 and 5. No, that wouldn't help you. 10 and 3. That wouldn't do you any good, would it? So nothing that I could factor 30 as would break down. So that's it. All right. And of course we've got say 4 plus 6 square root of 2 and 3 minus 5 square root of 2. Multiply those together. Well, that's like we've always done. That's FOIL, isn't it? Yeah, I'm going to take the 4 times the 3, that'll be 12. Then I'm going to take the 4 times the minus 5 square root of 2. That's a minus what? 4 times 5, 20 square root of 2. I'd multiply the 4 and the 5 there. Then I do the 6 square root of 2 times the 3. Well, the 6 and the 3 would be the ones I would combine there. It would be 18 square root of 2. And then 6 square root of 2 times minus 5 square root of 2. Well, there I've got two things I can combine. I can do the 6 times the negative 5. That's negative 30. And I can also, I needed to go ahead and do the square root of 2 times the square root of 2, which is square root of 4. And then simplify accordingly. Here I can simplify the middle two, right? I've got like radicals in the middle there. Can combine those. That would be, well, negative 20 plus 18 is negative 2. And the square root of 2 stays the square root of 2 when I add them. And then over here I've got, well, I've got the square root of 4, which is just 2. So negative 30 times 2 is negative 60, which makes then me able to combine the 12 with the minus 60, which is negative 48. Yeah, so it's FOIL all over again there. All right? Well, okay. Doesn't matter, but square root of 2 plus square root of 3. What if I square something like that? Write it twice. And FOIL, all right? Same thing. Yeah, if you have a squared binomial anything, 2 terms, added, subtracted terms in there, yeah, best bet is to write it twice and then do the FOIL like we did there. So we got the square root of 2 times the square root of 2, which is the square root of 4. Got the square root of 2 times the square root of 3, which is the square root of 6. I've got the square root of 3 times the square root of 2, which is the square root of 6, and then square root of 3 times the square root of 3, which is the square root of 9. Which does simplify a little bit. Of course, square root of 4 is 2. These are like radicals. They don't simplify individually, but they are like radicals, right? I've got 1 square root of 6, and I've got another 1 square root. That's 2 square roots of 6, isn't it? And then the square root of 9 is 3, which then that allows me 2 plus 3 to get 5 plus 2 square root of 6. With me on that? So yeah, all those things we encountered. Matter of fact, we encountered them also with the complex numbers. I'll mention those in just a second, though. Let me go ahead and mention one other thing on the radicals. We also talked about this thing. We did this. We rationalized some denominators. Which just means we want to take, say I've got 5 over the square root of 2. I want to rationalize the denominator. That just means get rid of the square root in the denominator. Yeah, so multiply by square root of 2, and you have to do that on the top and on the bottom, so that would be 5 square root of 2 on the top, because I can't combine the numbers there. And then on the bottom, I've got the square root of 2 times the square root of 2, which is the square root of 4, which the square root of 4 simplifies to be 2. All right, and what you want to watch for there is I can same thing, rationalize the denominator. So I've got 6 square root of 7 over square root of 3. Well, same deal. Multiply by the square root of 3 over square root of 3. Of course, on the top, I've got square root of 7 and square root of 3. I can combine those, square root of 21. And square root of 3, square root of 3 is square root of 9. Which gives me 6 square root of 21 over 3. And yeah, you want to watch for, well, I can simplify the 6 and the 3 here, can't I? I couldn't do it over here, the 5 and the 2, but the 6 and the 3 I can. Reduce by 3. So that one would wind up as 2 times the square root of 21. Is that okay? All right.